Hey guys, what is going on? It is your good buddy Sam, and it's time for another exciting Max MSP tutorial. Fear not, my brothers and sisters in the international Max workers conspiracy. The time of the Max revolution is close at hand, etc., etc. So it's no question, it's been a long time since the last video, and you might be thinking, Sam, is this a sign of old age? Are you over the hill? Is it time to put you out to pasture? The answer to that question is probably yes. But something, as long as people continue to get even some value out of these videos, I will try to continue to make them. Starting with this one, where I want to address something. There was a video, I think video 22, video reverb, where I showed how to take a matrix and use it, mix a new matrix with an old matrix in order to create these feedback type effects. And it all happened in jit.matrix on the CPU, and it's slow, and I feel bad this video exists because basically it's just wrong. It's just the wrong way to do things. So I wanted to make a new video to show how to do video reverb techniques, a basic pipeline that is more modern and actually will let you do interesting stuff without slowing down your computer and making everything stop working. So it all begins, as these patches so often do, with a jit.world. And I'm going to make a jit.world, and I'm going to do what we usually do with jit.world, which is throw in a toggle and a floating $1 so that we can activate audio processing by clicking this toggle and then turn on floating by hitting this toggle. So now this window is floating over here. And then having done that, I'm going to self-congratulate by saving this patch, and I'm going to save it to my desktop in a new folder called feedback cat. And I'm going to save this as cat. So this patch is called cat, and the reason it's called cat is because I have on my desktop this picture of a cat, this grumpy looking cat that I want to use in this patch. So I'm going to find this folder called feedback cat and drop this picture into it so that, in theory anyway, the Max patch can find this image. And because Max is a great program written by a cabal of geniuses, but is also a little bit flawed, I know for a fact that this patch won't be able to find that image until I close it and then reopen it. But now this patch should be able to find this cat image, and I can prove it by doing something like this: jit.gl.texture, and then making something like this. I think the thing is called cat. Yes, cat grumpy icon. So we'll do read cat grumpy icon.png. Bang. This, of course, will read the texture and then bang on the jit.gl.texture object so that it sends the image out. And there you go. There's the cat icon loaded into this jit.gl texture. And we're looking right here at the texture itself, stretched, of course, to fit this P window. So far, so good. What I want to do is draw it into this graphics context, though, not just into a P window. So I'll do what you usually do with this kind of stuff and do gl.videoplane. And now if I hit this again, there's the cat sitting on top of this video plane. So the first thing that you'll probably notice, there's two things that you might notice. One is that this cat has this black background behind it. It's very important. You can use whatever image you want in this video. You don't have to use this grumpy cat icon, but you do have to use an image that has a transparent background. I've just changed the image, the background of my window here in preview, so you can see that behind this cat there really is alpha. This is an image that has transparency, so it will have to be a PNG or some other kind of image format that supports transparency and not a JPG, JPEG as it's known by normal people, which doesn't have any alpha. So anyway, we've got this cat, and the question is why, if there's a transparent background, is this texture black instead of letting us see the gray erase color behind it? That's just because we haven't enabled blending for this video plane. So we should do jit.gl video plane at blend enable 1, And now the cat has disappeared. Why has the cat disappeared? It's because this video plane doesn't have a texture in it anymore. That's because we need to bang this jit.gl texture again. That's kind of a pain in the ass. So let's do this. Let's do send render bang out of the middle outlet of this jit.gl world, which will give us a bang before every frame, and then just hit this texture. And now you can see there's the cat sitting on top of this background, which is cool. One thing that I would like to do here is, so now what's the object of the game here for us? What I want to do is take this cat and I want to draw it to a texture. We've already done that, but I want to take it, capture it to a texture, do some transformations on it, and then draw it back to the window. In order to do that, I want to take what we've drawn here, this image, and capture it to a texture. We can do that with something called jit.gl.node. And I'm going to give this node a name at name cat-ctx context at capture 1. So this node is now set up to capture. So now it's basically it's reserved a texture, and other GL entities like this video plane, for example, can draw to it by setting their draw to parameter to be the name of this jit.gl node. So I can do at draw to cat-ctx, and now this video plane is rendering to this GL node, and you see there's nothing drawing in this window because the left outlet of this jit.gl node, which contains the captured texture, isn't drawing anywhere. So I'm going to make another jit.gl.videoplane, and this time do at transform reset 2, which basically takes the video plane and says, okay, ignore the actual position of this thing in the 3D world, just draw it to fill the screen. That's what that does. So now we've got this cat, we're throwing it on top of this. So we've got the cat, we're rendering it to this texture, drawing this texture into this video plane, using the GL camera to draw the cat once, and then rendering it to a texture, capturing that here, and drawing it again on top of another video plane. Which is, you might ask, what is the point of doing this whole elaborate song and dance just to basically take an image, draw it to two different places, and then draw it to the screen? Well, what it does is it gives us this here, the texture, that we can now do stuff with. First thing I'm going to want to do is make this cat a little bit smaller. There's an easy way to do that. We can just apply a scale transformation to this jit.gl video plane. One way to do that is by using an object called jit.anim.node. Basically, this lets you do transformations like scales, translations, and rotations on GL objects like this one. So I can do something like this, make a floating point box up here, do scale $1, $1, and then 1 without the dollar, so that I'm applying a scale to the X and Y values of this cat, but not the Z. And we can use this to zoom in and out, and I guess invert the image too, if we wanted to. And then having done that, now what I need to do is take this texture and do something to it. So in the space of doing something to that texture, what we're basically looking for is a shader. A shader is a program that runs on the GPU that works on, among other things, textures, which are images on the GPU. So I'm going to come over here and click on jitter and then on shaders. And you'll see a whole bunch of shaders here, and these are pre-programmed, well, pre-programmed in the sense they ship with Macs, and they do a lot of basic utility stuff. So all of these CC, they all begin with a certain, the pattern here is they all begin with a couple letters that indicate what they do. CC here, for example, works on color. CO here, these are compositing. These take two textures and blend them together. Matte is works with materials, so it determines how objects look depending on their surface qualities and also where light is in the scene, etc. The one that I'm interested in here right now is one called, well, it's got ROTA in the name. Yeah, this td.rota.jxs shader. And what this does, if I unlock the patch and drag it in, then what this does is this will let us take this texture and zoom in or out. So I'm going to connect it like this so that this texture goes through this shader. And then to find out, we can change what the shader does by modulating its parameters. To find out what the parameters are, you just lock and double click on this guy, and you'll see here, this is the description of what the shader does, what the program does in JXS, which is basically glsl. And if you want to learn glsl, or which stands for Graphics Language Shader Language, I think, what it does is just define a syntax for writing programs that compiled on the GPU. Well, actually, I don't know if they compile on the GPU. They certainly run on the GPU. I don't know where they compile. Who knows? Lots of people know, I'm sure. I got distracted. So these contain this, which is the meat of the program, as well as this. This is some jitter shader specific XML. Basically just defines these parameters, which have a name and a type. A vec2 is a list of 2 numbers, a float is a single number, etc., etc. So the reason that you want to open this up is because this lets you look at this parameter, name zoom. So now you know, okay, this shader has a parameter called zoom, and I can change its value. So we could do that by doing something like this. Param zoom $1, and this will let us adjust the zoom of this cat. There you go, zooming in and out. I can already see that this is maybe doing something that's going to annoy me. I think part of the problem here is that this GL node here, so you see this gray box here, I don't want that. And I think that's happening because this GL node has an erase color associated with it. And I don't want that erase color to be there. I want the erase color to be transparent. So we'll do @erase color 0000 here, so that this is always has a transparent background. And now the cat has disappeared because I've changed some stuff, and possibly this has caused something to come out of sync, which is a pain in the ass. If I delete and undo delete this, there's the cat again. And now everything's fine, of course. So sometimes this is the kind of nonsense that happens when you work with the jit.gl objects. Is I deleted this object, and that meant that this video plane didn't have anywhere to draw. And then when I brought this object back, this object was still unbound. So I had to delete this object and then reinstantiate it so that it bound again correctly to this render context. Shit like that happens. Cool, so there's the cat. Now what I want to do is set up the feedback loop. So this is the loop where this shader, after it does this rendering, we mix it with the old version of the matrix, of the texture rather, and do it all over again. So for that we need one more magical shader, and that magical shader is called co.alphablend. There it is. co.alphablend is a compositing shader, and what it does is take 2 different textures and blends them, where for each pixel it looks at the alpha value in the first channel, first texture rather. And if the alpha value is 0, it uses the right image, and if the alpha value is 1, it uses the left image. So it's basically like laying a transparency, one image on top of the other. So I'm gonna take this and do this kind of magic. Check this shit out. So I'm gonna connect it up like this, and then the whole crux of this thing is that after we do these transformations, so we take the image, comes through here, and we apply some kind of processing to it, and then if I do this, send old text, and then throw a receive old text up here, what that does, instantly you can see this kind of thing happening. We're like, we got this cat, we're zooming in, and then we apply the cat again, zoom in again, apply the cat again, zoom in again, and you get these kind of radial feedback patterns, which are nifty. So if you modulate the zoom now, you can make this guy, you can get this kind of shit going on, which is pretty nifty. And if you make the zoom really close to, but not quite 1, you get these, get this kind of melty thing going on, which is nice. And if you crank the zoom up, you get these tunnels, these cat tunnels going on, which is pretty good. So what I want to do now, I mean, we could end the video right here. That's, I think, pretty cool in and of itself. One thing that's kind of cool, like, it's always good to, like, it's fun to modulate these parameters kind of automatically. Okay, so this slab, for example, it also has this offset parameter. So one thing you could do is modulate this offset automatically. So let's build a really simple, like, noise oscillator or noise modulator. So we could just do like rand tilde 5. Is DSP on? No. Let's turn DSP. Let's turn DSP. Don't mess with me, Max. Easy DAC. Okay, now DSP is on. Rand tilde 5. Let's make a couple of these. And then do something like this. Snapshot 30 into a times 5. Let's get a couple of those going on. So just making two noisy LFO type things and then packing them together into a list. And then we can do param offset $1, $2 and throw this into this guy. And now the tunnel's kind of wiggling, and that's pretty cool. I'm into that. Yeah, it's especially cool when the zoom is relatively low, so you can really see the, the tunnel forming. And this is going to look better. I mean, the bigger this gets, the better it's going to look, because like you can actually see the separation between the two layers of the image. When it's a little preview like this, it kind of looks shitty, but you can see what's going on a bit better when it's bigger. So last thing I guess we could do, I don't know how long this video has been already. Okay, whatever. One more thing that we could do. I also have to go to work. Is the other thing that's going on here. So the last thing that we could do is so these shaders are defined in this glsl language, but with jit.gl pix. So gen basically for jitter. We can also define shaders using max patching. Which, by the way, it bears repeating, is the dopest shit of all time. So you can come into this patch and do something like jit.gl.pix. And then, if I double click on this, here's, we can define a shader here. So what I'd like to do is make a shader that, say, changes the hue, saturation, and lightness, messes with the color of the image. So let's start with an RGB to HSL. That takes this image and converts the red, green, blue values to hue, saturation, lightness values. And then let's split those up. So for that, you use an object called swizz. Swizz 0 gives you the first channel. Swizz 1 gives you the second. And this is going to really blow your mind. Swizz 2 will give you the third channel there. And then let's make a param hue and a param sat, so we can mess with the hue and saturation. Default value for hue is going to be 1. Sorry, default value for hue is going to be 0. Default value for sat is going to be 1. It's because I'm going to be adding the hue and multiplying the saturation. So these are going to be the identity values. And then we'll do plus hue for the hue and times sat for the saturation. And then we'll make a vec 0, 0, 0 to pack these values back together. Easiest shit of all time. And then just convert HSL back to RGB. Easy, 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 easy. So there's the full definition of this shader. And I can throw that in here now after doing this thing to the cat. Nothing's happening right now because we're not modulating the hue, saturation, and lightness. But if I do make a couple of number boxes here, I do something like hue $1, sat $1, and then set this hue to, I don't know, flippin', let's do 0.1. Yeah, now the color up here is going. So every time it feeds back through this thing, I rotate the hue just a little bit, which is definitely going to make things rainbowy. And the saturation, if I multiply the saturation by 0, it just grays everything. But if the saturation goes up to anything above 1, yeah, instantly you're going to get these kind of crazy rainbow things going on. Or pretty quickly you get these crazy rainbow things going on. which, you know, I mean, it's maybe a little cheesy, but, you know, it's okay. It depends if that's what you want or not. I can go wild with the stuff if you want. Yeah, it's pretty easy, especially if you do this kind of, look at this, so freaking stupid. It's actually kind of cool. I mean, this is kind of, if you, so this is doing this, yeah, it gets really out of control really fast, huh? What about negatives? Oh, okay. Epileptic warning. Yeah, inverting. Oh, jeez. Yeah, look away if there's... Damn, that's crazy. I like this. I like this a lot. That's kind of intense. Anyway, so that's kind of what I wanted to say in this video. You can see that the crux of this thing is that, you know, anything you want to do here at this part, between where you... so before generating the old texture, any effect that you want to apply and then feedback can do something really interesting. And that's basically all that I wanted to say. I hope that was an exciting and interesting video for you. And I promise there'll be more coming soon. I definitely plan on getting back into the swing of making these videos. But for now, thanks for watching, and I'll see you guys in the next video. Take it easy.